Hi, I'm Karen Jex, Senior Solutions Architect at Data, and I'm speaking at Posette about why you don't need a database backup policy. You're probably wondering why, as a DBA of over 20 years, I'd be telling you that you don't need a database backup policy. So hopefully this talk's going to be interesting to anybody who has data that they care about and want to keep safe. I've always worked with databases. I spent over 20 years as a database administrator, and I'm currently a Senior Solutions Architect with Data. So, of course, today I'm going to talk to you about why you don't need a database backup policy. And I can already hear you thinking something like, don't be ridiculous, Karen. Of course I need a database backup policy, although you might be using more colourful language. So let's look at why I might tell you that. First of all, just to make sure we're on the same page, what actually is a database backup policy? It's going to include things like the methods and the tools that you use to take backups of your database, how often you take backups and what kind of backups you take, where you're going to store those backups. Are they local? Are they in the cloud? Are you storing them to tape? And how long are you going to keep all of those backups? But how and why do you make all of those decisions? Let's try and find the answer to that question. So we'll look at why you take backups in the first place, what your recovery requirements are, the different methods and tools that are available to you to do database backup and recovery, how you might go about creating a disaster recovery policy, and the importance of testing and maintaining that disaster recovery policy. I'll concede that you almost certainly do need to take backups of your database. But let's think about why you take those backups. It's not just for the fun of scheduling some extra processes or to use up your storage quota. Your data are probably critical to you and you want to know that they're safe and available. So I'm assuming that you take backups so that you can recover your data if something goes wrong. But what could that something be that goes wrong? Fire? Flood? Explosion? Tornadoes? Usually, hopefully, it'll be nothing quite so dramatic. But it could be one of all sorts of different things that goes wrong, from a data center being unavailable, to your storage array failing, to Bob dropping a table, or a batch process incorrectly modifying data. In each of those situations, if you don't have another way to survive the failure, you might need to restore from a backup and recover your database to a point in time just before that point of failure. Remember, of course, that backups aren't the only way that you can safeguard your data. A database restore is actually often a last resort. You can survive a lot of failures if you've got a high availability architecture in place with one or more standby databases that can take over if there's a problem with your primary database. So now you know that you need to be able to recover your data if things go wrong. You need to know what's expected of you if there's a recovery situation, and there are a few main things to consider there. The first is your RPO, or recovery point objective, sometimes known as the maximum permitted data loss. So this is going to answer the question, how much data can you afford to lose? For a mission-critical database, that might be expressed in milliseconds or even as zero. Or on the other hand, for a development database, it might be expressed as a number of hours or even days. The second is your RTO, or recovery time objective. That one answers the question, what's the maximum amount of time it can take you to have your database back up and running? Or how long can the database be unavailable before it starts to become a problem? Generally, remember that the RTO actually says how quickly the entire application needs to be back up and running after a failure. So your database needs to be back up and running well within that time. As with the RPO, That could be expressed in milliseconds for critical databases or hours or days for non-essential databases. And then finally, you've got backup retention. How far back in time do you need to be able to go? Now, this might be for compliance or GDPR reasons. You might, for example, have to keep 10 years worth of data. On the other hand, you might not be allowed to keep certain backups for more than 6 months. And there may be nuances to how long you keep data. You may need to keep certain data online because you need to be able to restore recent data very quickly. And you might need to keep certain data for a certain amount of time offline because it might be okay for it to take several days or even longer to retrieve, for example, 6-month-old data. These recovery requirements are usually defined by the business, so they might be expressed as an SLA for either internal or external customers. If those requirements aren't explicitly defined somewhere, make sure to find out who's responsible and get it formalized. A poorly defined or moving target at best is extremely frustrating. Before you can put together any kind of policies or procedures, you need to know what the different options are for backing up and restoring your database. So let's do a quick recap of some of the different backup methods. When I talk about database backups, I'm usually thinking of physical backups. A physical backup is a file system level copy of the files that comprise your database cluster, i.e. the contents of your data directory. A physical database backup can be offline, where the database is shut down during the backup, although that's it's not very common to see that anymore, or online, where the database stays open and accessible to users during the backup. An online backup needs to include the WAL files that are generated during the backup itself so that you can recover to a consistent state if you need to restore that backup. An extension of the online backup is continuous WAL archiving. That's saving a copy of your WAL files alongside your backups. You can then use a backup plus the archived WAL files to recover your database to the state that it was in at any given time since that backup. So that's what we call point-in-time recovery, or PITR. There are different types of physical backup. A full backup is a complete copy of your database files, which, along with those WAL files that we discussed earlier, gives you everything you need to restore your database and recover to a consistent state. But full backups can take a lot of time and they can take a lot of space, even if you compress the backups. So let's imagine you take a weekly full backup. You take a full backup every Sunday. If you want to take additional backups during the week, you might decide to take incremental backups. An incremental backup only copies the changes that were made since the last backup of any type, rather than taking a copy of the entire database cluster. So you might, for example, decide to take an incremental backup on a Tuesday. You might take another incremental backup on a Thursday, which would back up only the changes that were made since Tuesday's incremental backup. If you needed to recover to Thursday, you'd need Sunday, Tuesday, and Thursday's backups to be combined to give you everything that you need to restore your database. You might decide on a Saturday, you're going to take a differential backup. Now, a differential backup backs up all of the changes that were made since the last full backup. So this one will ignore the fact that we took an incremental backup on Tuesday and Thursday, and it will back up all of the changes that were made since Sunday's full backup. If you needed to recover to Saturday, you could take just Sunday's full backup plus Saturday's differential backup to get back to Saturday. And then on Sunday, you're back to your full backup, ready for the new week. A storage snapshot is essentially an image of a file system at a given point. Different storage vendors implement storage snapshots in different ways with different solutions, different architecture, and different functionality. In some organizations, storage snapshots are used as part of a database backup strategy. Storage snapshots can be a very fast way to back up a file system, but there are a few things that you need to be aware of that can trip you up if you choose to use them as part of your database backup strategy. You need to make sure that your file system supports the ability to create a consistent snapshot of the data directory. You must back up the WAL files alongside the other database files so that the WAL can be replayed when your backup is restored. Remember that Postgres will do a crash recovery when the database is started after it's been restored from a storage snapshot. In order to reduce recovery time, you can perform a checkpoint before the storage snapshot. If the WAL files and data files are on different disks, or if you have table spaces on different file systems, you need to make sure that your storage vendor supports creating simultaneous frozen snapshots of all the volumes so that you've got a copy of all of them at exactly the same time. You need to read the file system documentation carefully, and as with any other backup strategy, you need to test your entire backup and recovery process. A logical backup, otherwise known as a database dump or an export, is an extract of some or all of the data or the objects within your database cluster. It's dumped in the form of SQL commands that can be executed so that you can recreate those database objects. The restore from a logical backup, sometimes called an import, and the dump can either be imported back into your original database cluster or into a different one. So just a quick recap of the features of the different methods that we've talked about. So as you can see, the only method of backup that will give you the ability to do point-in-time recovery is continuous archiving. So you need online backups and continuous archiving of your WAL files. If you need to be able to do things like restoring a single object, or you need to be able to restore across different platforms or versions, you'll need to take logical backups or exports. And you'll probably need to combine these methods to give you everything that you need. There are various Postgres backup and recovery tools available, and the tool or tools that you choose will very much depend on your requirements. There's a whole host of things that you might need your backup and recovery tool to do, from point-in-time recovery to a centralized backup architecture with backup catalog, to backup and WAL file retention policies. You might need multiple backup locations, including cloud storage, compression of your backup and WAL files, or backup and restore of individual databases, schemas, or tables. So the main tools available for Postgres backup and recovery: PG Backrest is a fully featured, reliable, open source backup and recovery tool that's used by much of the Postgres community. Barman is another open source backup and restore solution. And PG Base Backup is integral to Postgres, and that lets you build your own backup and recovery around its functionality. PG Dump exports or dumps a single database, or if you prefer, just certain objects from it, either as a plain text file that contains the SQL commands that allow you to reconstruct the database, or in a custom archive format that can be restored and imported by PG Restore. PG Dump All will export all of the databases and all of the global objects, so users, etc., from your database cluster. Okay, so now you can start to design and, most importantly, document your disaster recovery strategy. What do you need to put in it? We'll just quickly go through each part in turn. First, you'll need a clear statement of your recovery requirements. Your recovery requirements will vary almost certainly depending on the type of application. So you might organize your applications into categories. and that will depend on how critical they are. And then you can define recovery requirements for each category of application. Mission critical client-facing applications will be categorized as level 1. And you probably also want the office coffee machine system to go into that category if you want your tech staff to keep working efficiently. And that will go through to non-essential internal systems, for example, things like your internal print services, classified as level 4, low priority. This is probably going to be part of a wider categorizing of applications within your entire organization, and it might impact other policies such as security and high availability. You'll need to think about responsibilities. Who's responsible for each aspect? Who's going to be contacted in an emergency? Who signs off on any action? Since database recovery is only one part of your organization's overall disaster recovery, you'll probably also need to coordinate with other teams. To design and document your recovery procedures, you need to consider each possible failure that you can imagine, and then work out what impact that failure is going to have on your database and application, and how you would recover from it, including expected timings. Each category of application that you already defined with its different requirements will probably need different methods. We'll look at just a couple of possible failure scenarios and see what the thought process would be there. What happens if you lose your primary database node? With a high availability architecture in place, you'll encounter a brief unavailability whilst the HA system detects the issue and performs an automatic failover to one of your standby databases. You'll have to replay any in-flight transactions, and you might lose data associated with some committed transactions if you're using asynchronous replication. The recovery time should be in the order of seconds, depending on the timeouts that you've got configured in your HA architecture. You'll afterwards have to do some work to rebuild your own primary and reintegrate it into your HA cluster as a standby, but that's done whilst the system's up and running, so it doesn't contribute to the downtime. So your recovery timeline might look something like this, with a very short unavailability. If you have a standalone database, you don't have a standby to take over if the primary or only database fails, so you'll need to restore from backup, and the database will be unavailable whilst you do that. If you're doing online backups of your database and archiving all of the WAL files between backups, you can have minimal data loss, as a general rule, a maximum of 1 WAL file. And recovery time is going to depend on various factors. It will depend on the size of your database, the speed of your disks, whether or not you have to set up a new Postgres node before you can restore, how much WAL needs to be replayed, etc., etc. Let's say your database takes 45 minutes to restore and recover. In that case, your recovery timeline might look like this. You've got 45 minutes there of unavailability whilst you wait for that restore to happen. What about if a batch process goes wrong? Say you have a batch process that runs at 7 a.m. to ingest files that were provided overnight. The process takes half an hour. At 8 a.m., you notice that something went wrong. Maybe part of the process fails, maybe some files were processed that shouldn't have been. If you're lucky, you've got a window between 7 a.m. and 8 a.m. where nothing else is going on in the database. On the other hand, you might have transactions going on in the database at the same time. Perhaps it's just a slightly quieter period. That's going to have an impact on which recovery process you choose to use. What are some of the options? Well, you could restore from backup and perform a point-in-time recovery to just before the batch process. You could recover to a separate server, export the impacted tables and import them back into your primary database. Or you might be lucky enough to be able to script the corrections, which obviously you would test on a copy of your primary database first. If there was no other activity during the batch process, you might be happy to take the whole database back to 7 a.m. just before the batch started. So your procedure might be an in-place database restore and point-in-time recovery. In this case, your recovery time is 45 minutes and the database is completely unavailable during that time. You might then need to keep the application shut down for longer whilst you rerun the failed batch process, or maybe it can be pushed to tomorrow's batch window. If, on the other hand, there was normal activity on the database between 7 a.m. and 8 a.m., you probably don't want to take the whole database back to 7 a.m. and lose an hour's worth of transactions. There's a good chance, luckily, that the set of tables impacted by the batch aren't the same ones that are being accessed by the application. Otherwise, you probably wouldn't have normal activity going on at the same time. So in that case, you might decide to restore a separate copy of the database cluster from a backup using point-in-time recovery again, just before 7 a.m. You could then export the impacted tables from the copy and import them back into your primary database. So in this case, assuming that it's taking us 45 minutes to do that export and import of the data, the entire process takes longer than in the previous case. It takes 90 minutes in this case, but your database and application are still available throughout that process and you don't lose the transactions that happened between 7 a.m. and 8 a.m. In general, a high availability architecture isn't going to help in this case. The changes applied to the primary will be copied over to the standbys, so you've just now got multiple incorrect versions of the data. But there is a workaround. You could create a delayed replica using the recovery min-apply delay parameter. Since your batch job takes 30 minutes, if you set that, for example, to 1 hour for one of your standbys, that would give you 30 minutes between the end of the batch job and the changes being applied to that standby where you could check that everything had happened correctly. If not, you've got time then to export the good data, the pre-batch data from that delayed standby and re-import it into your primary database. Make sure every scenario is clearly documented and automated as far as possible, and test each scenario. You want to note the approximate timings of each recovery because in an emergency, people will always want to know how long till we're back up and running is. The disaster recovery equivalent of, are we nearly there yet? Then test again, just to be sure, and plan to test your recoveries regularly and preferably have other people test them. And finally, the backup strategy that you're going to put in place to respond to all of those recovery requirements. For each category of application, you want to note the backup method. Are you going to do physical or logical backups, online or offline? Do you need continuous archiving? Obviously, as we've said before, you might need to be using more than one of those methods. How often are you going to take backups? Are you going to take a full backup weekly and then a daily incremental? Are you going to do a full once a week and then a differential midweek, for example? How long are you going to keep those backups? A week, a month, just a couple of days? Are you going to keep a week of backups online and then a year's worth offline, for example? And you need to include a policy for monitoring the backups to make sure they're happening as expected. You need to keep track of how big your backups are, how much wall you're generating. Make sure that there's enough space available on your backup volumes. Be aware of how long your backups take. Check that your backups are valid. I've had customers who found out during a restore that some of the files were missing from their backup set, and that is obviously the worst possible time to find that out. So now you should have a documented disaster recovery policy that includes a statement of your recovery requirements, the backup strategy that you've designed to respond to those requirements, the recovery procedures that you're going to follow in the case of failure, including expected timings, and a statement of who's responsible for each aspect. Putting that documentation together is far from the end of the story. You need to be performing regular testing of all of the procedures, and you need to keep the documentation up to date. I live in the mountains, and even though I have snow tires, I keep chains in my car all winter as a backup policy, just in case I get stuck somewhere. But there's no point carrying snow chains if you don't know how to use them. It's much better to practice putting them on calmly at home before the winter, rather than trying for the first time in a snowstorm in the dark in an emergency. And you probably want to practice that before every winter season, just to make sure you remember how to do it. For very similar reasons, you need to test your recovery strategy and plan to test it regularly. As a finger in the air type estimate, I'd say at least every 6 months, but preferably more often, and certainly anytime someone new comes onto the team. If you have to restore, it's likely to be an emergency. It'll be the middle of the night. There'll be no one around to help. There'll be irate users and managers desperate for the database to be back up and running 10 minutes ago. And there's a good chance that the person who wrote the recovery procedures left the company last year. You don't want to be trying out your restore procedure for the first time in that kind of situation. You want to have done it many times before. You want to know exactly what you're doing and how long it's likely to take. If you can confidently say, this is fine, or rather, I'm following X procedure, I expect the database to be back up and running in N minutes, and after that, I'll perform Y tests to make sure everything's as expected, then people might just leave you alone to get on with it. Review and update the policy regularly, at least annually or any time there's any kind of major architectural change. Requirements might have changed, tools might have changed, the database size will almost certainly have changed. So the procedures for testing, reviewing, and updating the policy should form an integral part of your actual disaster recovery policy. So your backup strategy is just one part of your database disaster recovery policy. The backups really are there to support your database recovery. First, make sure you've got well-defined and documented recovery requirements. Implement a backup strategy that responds to those recovery requirements for as many scenarios as you can think of. It might be with a combination of methods and tools. High availability architecture, online backups with continuous archiving, regular database dumps, storage snapshots, etc. Be aware that the database exists within a wider environment. Database recovery is probably just one small part of your organization's overall DR policies. Collaborate and communicate with other teams. Test and practice your recovery. Have a plan in place to make sure this happens frequently. And keep your documentation up to date to keep up with changes in policy, database size, the use, and any other changes that might happen. So the real conclusion is that you don't need a database backup policy, but you absolutely do need a database disaster recovery policy. Thank you so much for listening.